Hello everyone. In this video, I'm going to talk about one specific type of reactions. We call that single displacement reaction. We are going to learn how to apply activity series of elements to write products of this reaction. First, I'm going to remind you a general pattern of this specific type of reaction. First, if we have A plus BC, we call that single displacement reaction because A represents element and BC represent a compound. So whenever we have a reaction between an element and one compound, we call that single displacement reaction. During this reaction, A as element should be written here. In other words, we are going to replace B by A. We are going to replace B by A. So A should be written here. We have this replacement. We call that AC, and B is released. During this reaction, as you see, we are going to make one compound and we are going to make one element. So how to identify single displacement reaction when you have elements and compound in the reactant side, and also you may say if we have compound and element on the product side as well. As you see here, we use activity series of elements to predict the products of single displacement reaction. You do not need to memorize any info regarding this table. So always during your evaluation time, exams, quizzes, you have access to activity series of elements. Let me give you this list of elements, this activity series of metals. I say activity series of elements. So when we talk about metals, it means we focus on only metals. We do have activity series of non-metals, and totally we have a general activity series of elements. For our class, we are going to focus on activity series of metals to answer the single displacement reactions. As you see here, we have a list of elements, metallic elements here, and we assume that hydrogen is our metal elements because it's placed on group number 1. Let me back to the previous slide. So no worries regarding having activity series of elements on your exam. The only rule we need to apply to solve our problems and writing the products is activity of elements must be higher than activity of cation in the ionic compounds. We are going to know what does that mean. Please look at this slide. In this slide, I just ask you to please pay attention to this terminology here. We write most active elements on the top and least active elements on the bottom. So in this series, lithium is most active elements, and as we go down in this series, gold is going to be least active elements in this series. If we are going to work on redox reaction, we are going to use another terminology or another concept related to this series. So if I'm going to compare, I can easily compare based on this ordering. And we are going to consider that one. Activity of elements must be higher than activity of cation. First, let me give you one example. Let me give you one example. Assume that in our example we have magnesium and copper 2 chloride. Reaction of one element and compound. We call that single displacement reaction. Magnesium is metal, solid at room temperature, and copper 2 chloride, based on the solubility rules, you can easily find aqueous. So I am sure you already watched another video in this series. You can easily predict solubility of copper 2 chloride. We are going to know what is the product for this reaction. So the rule is activity of element Mg must be higher than activity of cation, copper here. Let's try. Let's see how it works. We need to find magnesium. Magnesium in this series is here. And we need to find copper. Copper is here. So it says activity of magnesium must be higher than activity of copper. As you see here, it works. Magnesium has higher activity than copper because it's placed on the top. So we are going to write the products for this reaction. Magnesium must be written here. So we are going to replace copper by magnesium. So I'm going to write MgCl and I'm going to write copper. To write the products, you should remember that when we are going to have two ions, cation and ions, we are going to make ionic compounds. Mg, it says 2 positive, and we know that Mg group number 2, 2 positive. Chlorine group number 7, 1 negative. So when you switch the ion charge, so I'm going to write it here. Magnesium 1 and Cl2. And we don't write 1 for Mg. So the formula is MgCl2 plus copper. So I wrote the products for this reaction. Right now, I may determine solubility of the compound MgCl2. We don't have a rule for magnesium. Based on the solubility rules for halogens, halide, we have aqueous solution. Copper is solid at room temperature because this is a metal. So we do have this reaction and we can work on this. So let me have a quick review. If we have the periodic table of elements, so you just need to look at the table and find two ions, one element, another cation of the compound. If, again, this is the rule. If activity of element is would be higher than activity of cation, we do have the reaction. So for this example, as you saw here, we compare activity of magnesium and copper, and we see that magnesium has higher activity than copper. That is why we write like this one as product of the reaction. Let me work on another one. One example, chromium plus NaCl, NaBr, like this one. Element, compound, we call that single displacement reaction. Chromium, metal, solid at room temperature. NaBr, we write aqueous because group 1 element. Right now, we are going to check activity of each one. First, I have to know this activity. Chromium must have higher activity than Na. Element must have higher activity than cation. So I'm going to find this. Chromium is here and sodium is here. Chromium has less activity than sodium. So we cannot have this displacement. We need to use energy. So we cannot do this experiment simultaneously. So we say that no reaction, no reaction. So it looks sometimes we do not have reaction because we do not have activity of element is enough high to be replaced by the another one. So that is why we say Na has higher activity than chromium. So we cannot switch or change the element and cation. Assume that we have this question on your exam. To answer that one, you check chromium and sodium, and you saw that chromium activity series is less than, in the activity series table, chromium has less activity than sodium. That is why we say no reaction. So we do not have any reaction for this example. Right now, I'm gonna work on another example. Let me work on this example. Zinc plus HCl. Zinc, solid, HCl, all acids are soluble in water aqueous. It doesn't matter what are our anions, HNO3, H2SO4. Always we check, we compare activity series of metal element and activity series of cation. So if I have this activity series, check this activity in this activity series. Activity of zinc must be higher than hydrogen. Let's try. Zinc is here, hydrogen is here. So it looks zinc is higher than hydrogen. So we do have this reaction. We do have this reaction. So zinc must be written here. So we are going to replace H by Zn. So I'm going to write ZnCl and I'm going to write H. First, zinc is transition metal. For transition metals, we have a variety of ions. We are going to know what ions should be written here. So for zinc, it says zinc 2 positive. We already knew that. For zinc, always we have zinc 2 positive. But if we have any other transition metals like Fe, like tin, or so on, we look at the charge here and we apply the charge. So zinc is zinc 2 positive. I'm going to write here Zn2 positive, Cl 1 negative. So we are going to switch the charges. So ZnCl2. And please remember that hydrogen always exists as H2, as a diatomic molecule. Right now, I'm gonna write solubility of ZnCl2. Because we have aqueous here, I'm going to check the solubility. ZnCl2, based on the rule number 3 on the solubility table that I already talked about this in other video, so you should write aqueous. For halogens, we have all zinc chloride soluble compounds. Regarding the hydrogen, as a diatomic molecule, we write G, we write gas. Then you are going to balance the reaction by yourself. So you are going to add number 2, for example. So we absolutely have the reaction here. We absolutely have the reaction here. Again, the reason because activity series of zinc is greater than hydrogen, that is why we are going to have this replacement. Hope these 3 examples help you to understand the activity series of element, how to write the products. Please understand, we have no reaction if activity of element less than activity of cation. Thank you for watching this video.